compact fluorescent lamp, or CFL, cannot be used in a hazardous rated incandescent fixture. Hazardous locations are defined as areas where fire or explosion hazards may exist due to flammable gases, vapors, liquids, combustible dust, or ignitable fibers or flyings. These locations are classified based on the type and frequency of the hazardous material present. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dust, and Class 3 locations involve ignitable fibers or flyings. Within each class, divisions further specify the likelihood of the hazardous material being present in ignitable concentrations. Division 1 indicates that the hazardous material is likely to be present under normal operating conditions, while Division 2 indicates that the hazardous material is only likely to be present under abnormal conditions. Hazardous rated fixtures are specifically designed and tested to contain any internal ignition and prevent it from propagating to the surrounding hazardous atmosphere. Incandescent fixtures designed for hazardous locations achieve this through robust construction, sealed enclosures, and the use of heat-resistant materials. These fixtures are typically rated for specific temperature ranges and are designed to prevent the surface temperature from exceeding the ignition temperature of the hazardous material present. Using a CFL in a hazardous rated incandescent fixture introduces several safety concerns. Firstly, CFL contain electronic components, including a ballast that can generate sparks or arcs during normal operation or failure. These sparks could ignite a flammable atmosphere in a hazardous location, leading to an explosion or fire. Secondly, CFL are not designed to operate in the high-temperature environments that can exist within hazardous-rated incandescent fixtures. The increased temperature can damage the CFL electronic components, reducing its lifespan and increasing the risk of failure. Thirdly, CFL may not meet the temperature rating requirements for hazardous locations. Hazardous rated fixtures are designed to limit the surface temperature of the lamp and fixture to prevent ignition of flammable materials. CFL may not have the same thermal characteristics as incandescent lamps and could exceed the temperature limits, creating a safety hazard. The National Electrical Code, or NEC, provides specific requirements for electrical equipment installed in hazardous locations. Article 500 covers the general requirements for hazardous locations, while Articles 501, 502, and 503 provide specific requirements for Class 1, Class 2, and Class 3 locations, respectively. These articles mandate the use of equipment that is specifically listed and labeled for the hazardous location in which it is installed. Using a CFL in a hazardous-rated incandescent fixture would violate these code requirements, as the CFL is not listed or labeled for use in hazardous locations. The listing and labeling process involves rigorous testing and evaluation by a nationally recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that the equipment meets the safety standards for hazardous locations. Equipment that is not listed and labeled has not been evaluated for use in hazardous locations and may pose a significant safety risk. There are several alternative lighting solutions that are suitable for use in hazardous locations. Firstly, explosion-proof LED fixtures are specifically designed and tested for use in Class 1, Division 1, and Division 2 locations. These fixtures feature robust construction, sealed enclosures, and temperature ratings that meet the requirements for hazardous locations. LED offers several advantages over incandescent and fluorescent lamps, including higher energy efficiency, longer lifespan, and improved durability. Secondly, intrinsically safe lighting systems are another option for hazardous locations. Intrinsically safe systems are designed to limit the energy available in the electrical circuit to a level that is too low to ignite a flammable atmosphere. These systems typically use low-voltage power supplies and specially designed fixtures that are certified for intrinsically safe operation. Thirdly, purged and pressurized lighting systems can be used in hazardous locations. These systems involve enclosing the lighting fixture in an enclosure that is purged with clean air or an inert gas to prevent the accumulation of flammable materials. The enclosure is then pressurized to maintain a positive pressure and prevent the ingress of hazardous materials. When selecting a lighting solution for a hazardous location, it is important to consider the specific requirements of the location, including the class, division, and group. The class refers to the type of hazardous material present, the division refers to the likelihood of the hazardous material being present, and the group refers to the specific chemical or substance that is present. The lighting fixture must be listed and labeled for the appropriate class, division, and group to ensure safe and reliable operation. It is also important to consider the temperature rating of the lighting fixture. The temperature rating indicates the maximum surface temperature of the fixture under normal operating conditions. The temperature rating must be below the ignition temperature of the hazardous material present to prevent ignition. The NEC provides guidance on selecting the appropriate temperature rating for different hazardous materials. For example, NEC Table 500.5d provides temperature identification numbers for various flammable gases and vapors. In addition to selecting the appropriate lighting fixture, it is also important to ensure that the installation meets the requirements of the NEC and other applicable codes and standards. This includes proper wiring, grounding, and bonding to prevent the accumulation of static electricity, which can also be a source of ignition in hazardous locations. It is also important to follow the manufacturer's instructions for installation and maintenance to ensure that the lighting fixture operates safely and reliably. Regular inspections and maintenance should be performed to identify and correct any potential problems, such as loose connections, damaged wiring, or malfunctioning components. In summary, using a CFL in a hazardous rated incandescent fixture is not permitted due to safety concerns and code violations. Hazardous rated fixtures are specifically designed and tested to contain any internal ignition and prevent it from propagating to the surrounding hazardous atmosphere. CFL contain electronic components that can generate sparks or arcs, are not designed to operate in high-temperature environments, and may not meet the temperature rating requirements for hazardous locations. The NEC requires the use of equipment that is specifically listed and labeled for the hazardous location in which it is installed. Alternative lighting solutions for hazardous locations include explosion-proof LED fixtures, intrinsically safe lighting systems, and purged and pressurized lighting systems. When selecting a lighting solution for a hazardous location, it is important to consider the specific requirements of the location, including the class, division, and group, as well as the temperature rating of the fixture. Proper installation and maintenance are also essential to ensure safe and reliable operation. Always consult with a qualified electrical professional to ensure that the lighting system meets all applicable codes and standards. The NEC, specifically Articles 500 through 505, provides detailed requirements for electrical installations in hazardous locations. These articles cover topics such as classification of hazardous locations, wiring methods, equipment grounding, and sealing requirements. It is essential to have a thorough understanding of these requirements to ensure that the electrical system is installed and maintained safely. For example, in Class 1, Division 1 locations, all electrical equipment must be explosion-proof, meaning that it is designed to contain any internal explosion without igniting the surrounding atmosphere. Wiring methods in these locations must also be designed to prevent the propagation of explosions. In Class 2, Division 1 locations, equipment must be dust ignition proof, meaning that it is designed to prevent the entry of dust and to prevent any internal arcs or sparks from igniting the dust. Wiring methods in these locations must also be designed to prevent the accumulation of dust. In Class 3, Division 1 locations, equipment must be designed to minimize the accumulation of fibers and flyings and to prevent any internal arcs or sparks from igniting the fibers or flyings. Wiring methods in these locations must also be designed to prevent the accumulation of fibers and flyings. In addition to the specific requirements for each class and division, the NEC also provides general requirements for electrical installations in hazardous locations. These requirements include bonding and grounding to prevent the accumulation of static electricity, sealing to prevent the migration of flammable materials, and the use of intrinsically safe circuits. It is also important to consider the ambient temperature in hazardous locations. High ambient temperatures can affect the performance of electrical equipment and can increase the risk of ignition. The NEC requires that equipment be rated for the maximum ambient temperature in which it will be used. When selecting electrical equipment for hazardous locations, it is important to consult the manufacturer's specifications to ensure that the equipment is suitable for the intended application. The manufacturer's specifications will provide information on the equipment's class, division, group, temperature rating, and other relevant characteristics. It is also important to ensure that the equipment is properly installed and maintained in accordance with the manufacturer's instructions. Improper installation or maintenance can compromise the safety of the equipment and increase the risk of ignition. Regular inspections should be conducted to identify any potential problems, such as loose connections, damaged wiring, or malfunctioning components. Any problems should be corrected promptly to prevent a hazardous situation from developing. The use of qualified electrical personnel is essential for the safe installation and maintenance of electrical equipment in hazardous locations. Qualified personnel have the knowledge, skills, and experience necessary to properly select, install, and maintain electrical equipment in hazardous locations. They are also familiar with the requirements of the NEC and other applicable codes and standards. In addition to the NEC, other codes and standards may also apply to electrical installations in hazardous locations. These may include state and local codes, as well as industry standards such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be familiar with all applicable codes and standards to ensure that the electrical installation is safe and compliant. The selection of lighting for hazardous locations is a critical aspect of overall safety. By understanding the hazards, classifications, and available technologies, appropriate lighting solutions can be implemented to minimize risk. Adherence to the National Electrical Code and other relevant standards, along with proper installation and maintenance, further ensures a safe environment. Remember, when working with electrical systems in hazardous locations, safety is paramount. Always consult with qualified professionals and adhere to all applicable codes and standards.